Okay, now I'm going to demonstrate running the VBM analysis on HiperGator. And in reality, this is just most of the setup to run it because it will take a little while to run. But what we do is we can go to the on-demand site and go to the class directory. You can also do this in a terminal using SSH if you prefer that method, but I'm going to take the more visual approach for the class. Then I go into share, and now there is a file called oavbm.zip. So copy that into your subdirectory. And so I'll copy and paste. Again, you can also do this on the command line. And now we need to extract it. So I'm going to open in terminal. I'll list the contents of the directory just to verify that we're where we think we are. And then type in a command called unzip, and then the oavbm.zip. And then this will extract the files, and should be pretty fast to do. And then I'm going to remove the zip file. You don't have to do that, but that will just clean up my folder a little bit. And now I can go into a new folder. Let me list the contents first. So now we have this oavbm, and that is a directory. So I can list the contents of that directory. I can list the contents of the directory and put this little flag -1. So that's not an L, that is a 1. And that will list the contents of the directory and put each file on a new line. And so we can see everything that's in there. And I can also come to the File Explorer. If I refresh this, I can go in there and we can see all the files in there. And so the nice thing about this is, of course, we can just look at it. You don't have to type in the commands, but we're doing the same thing over here in the terminal. Now, if I want to verify how many files are in here, so this is an analysis. We have 66 research participants, 33 are control, 33 have knee osteoarthritis, the OA, and so we have a con prefix and an OA prefix, and so these are all set up for you already. But this was following the FSL VBM user guide. So if you do a Google search for FSL VBM, there should be a link to the user guide, and it's also in the module for the assignment. But this tells you the general flow and setup of doing the analysis. And so the VBM analysis is pretty straightforward. What we've already done is I've already renamed and copied these files into the directory for you. And so that's what we have here. They are T1 files. I didn't specify T1 just to keep the name shorter, but ideally you'd probably want to specify what they are, so then if you ever had a question about what are these files, then that would have it in the file name. But because I've set this up and this is a very specific type of analysis, it doesn't really matter that much. And the only thing we want to be aware of is if we're going to do say a between group analysis, I want to compare a control group with a patient group, then we want to make sure that all of the control participants, all of patient participants in these two groups are all together. They're grouped within their groups. And that's why the prefixes are con and OA. And so OA would be my patient group, if you will. And by convention, the control group goes first. And so whatever you need to do to name the files, if you're setting this up your own, if you just put the control group first. You don't have to, but if you do, then it's consistent for every analysis you do. And so then when you're trying to interpret results, you know what the results are and really how to interpret them, which group has what difference. So the controls, again, are first, and then they also have their participant ID, and these will all get sorted alphabetical order and smallest to largest. And that's important to understand the sorting in here, because when we are setting up the GLM, you're going to put in all the participant data whatever the grouping variables are, or whatever the any covariates you might have for variables of interest, then you need to make sure that they match the sorting. And if you only had one group, let's say you're interested in is there a relationship between gray matter density, which is technically what we are assessing with a VBM analysis. If there's a relationship between gray matter density and, let's say, duration of chronic pain, then we would only have one group. In that case, you wouldn't have to have some prefix. You could have a prefix, but you could just have their IDs, and as long as everything's sorted in the appropriate manner, meaning the order that this is sorting is matching the order that you're pulling the data in from a spreadsheet, then or a database, then that's fine. But in our case, we're going to do a between group analysis. And so I have our group set up. So now what we need to do is keep following the guide. And I also have these really in the module in a page. And so really it's after everything's set up, we just run these 3 commands. We can just put them in a script. And so that's what we're going to do now. So I'm going to do these in my text editor. And this is Visual Studio Code. I made sure my line endings are LF. This is done on a Windows computer, so it defaults to the CRLF. If you're doing this on Mac, or if you're using something else, it should default. But again, line endings can be an issue if we're going between Windows and in a Linux computer. So HiperGator is Linux. So what I'm going to do is we want to set up our script. So I come over to the sample Slurm scripts. You can go to help.rc.ufl.edu and then find the sample scripts. And this is a basic single-threaded job, so I'm just going to copy these first lines into my script. And then I will change this. I'm going to call this our, I'm just going to give it a name. I'll put my initials on there. And then that's fine. This is going to be one job. So it's okay I'm okay getting an email at end and fail. You can do all if you want the email, since it's just one job. I'm just used to running lots of jobs at the same time, so I don't like having end in there, but let's just give this an all so we can see when it starts. I'll put my email address in there. And then I'm going to give this some more RAM. 4 gigabytes should be fine. Now, this could take a little while to run. I'm not sure exactly how long it will take. So I'm going to give this, I don't know, let's give this 60 hours. Let me give it 72 hours. It should be done within 48 hours. I ran this locally on my computer and it took, I think it only took about 24 hours. So really it shouldn't take that long to do, but I'd rather be safe than sorry. We can request more time. That's not really a problem. And then I'm just going to change this name for the log file, and then we keep those commands. So now we need to do a couple things. We need to module load FSL, and then I'm going to go into this directory. So I can copy this from here, and then I'm going to go into the OA VBM directory, and so I will copy this path. So if you're using this online terminal with the on-demand service, if you highlight, it'll automatically copy. So I can come over here and just paste that in. And so then that's the path. It's not a very complex path. For you, again, it should just be replacing the share and this your Gator link and then the OA VBM. So this is pretty straightforward. So we're going to do that. And then you can just copy these commands from the module page. So what are these commands? So we have, and you can keep the space between them, it's fine, it's not really an issue, I was just getting rid of it. So the first step is going to be the brain extraction. And I'm going to use the -N. So this is coming from the guide. So -N will remove neck if there happens to be a lot of neck. And I don't know if that's the case for these data, but these are sagittal acquisitions, so there tends to be a fair amount of neck. And so what I'm doing is just using that option, and these are ones that I tested already, so I know they work. And so then I'm going to put in this -F, which is the fractional value. This is coming from the bet values. So we went over bet last week, but I'm going to do a -F.3, and you can do the 0.3, and that's just going to have the brain be a little bit larger if needed, which is going to be okay. And so I find that that works better than the default. So this FSL VBM _1 bet -N -F 0.3. Again, you can just copy these from our module. And then that's the first step. So that's going to do brain extraction. And then our template. And if we come look at the user guide, doing the -N is going to do a non-linear registration. This is going to take longer, but so essentially what is happening is for VBM is you create what's called a template brain, but this is what we call a study-specific template. So it takes your images and it will average them all together, puts them all in the same space, average them together to create a template. And this is going to be in M&I space, or actually this ICBM 152 space, but as I was saying, but really it's an M&I space brain. Here's how we can think about it. It's a standard space, and scratch that. Sorry, it is a little bit different than M&I 152, and but this ICBM 152 template is the space that it's creating a template. So this is what we call, again, a study-specific template. Don't need to worry so much about it, but this is what is the appropriate method to do a VBM analysis. And so that way, all of the brains are represented within your sample and from everybody in your sample, ideally. And then that way, when you're lining the brains up together, you're going to line them up to this template that was created from their study, and it should get a better registration. And so we're going to use this command FSL VBM2 template -N. You could do the -A. It would be a faster run, but we have time. And so that's going to be the next step. And then the last one, FSL VBM3 proc. And so that is processing the native gray matter images. So there's going to be a tissue type segmentation done in here. And so we did that as part of our FSL ANAT. This will be done again in this step. In a parallel way, that's fine. And then this final step will do a nonlinear registration of all your gray matter images to that study-specific template and merge them all into one file. And then it will create some other images. So those are the first steps. So that's what we're putting in our script. And that's all the script is really going to be. And so then I'm just going to put date at the end so we know when it is done. Now I can save this and upload it, or I can just copy this and then come into either this directory. I'm actually going to go up a directory, and I have a code folder, so I'm going to go into my code folder, and then I'm going to do nano, and this is going to be my OA VBM, and then I will paste this in. And I can put this script in that code directory, because in here I have CD. We go into the proper directory to run this. And then I can save it, so Control O will save it, and then Control X to exit. And so now if I list, I can verify I have a OA-VBM.sh. And now I can submit this as batch OA-VBM.sh. And I just realized I need to change my account. So let me add 2 more lines to here. So I'm doing this in nano. So account, I'm just going to put the class account. And again, if you have multiple accounts, which some of you do, then go ahead and use the class account so you don't use your Research Mentors account. I could use my other account. I just wanted to show that you should really be using the class account. And I wanted to switch over to use it. And so I'm going to use that account instead of my personal account. And then I will submit it. And it'll just take a little bit to go. So I can type in a command called SQ-A. And then I can do CLP 7934 for our class. There's a couple things running. Here's my new script. The other one is a console session that I'm running. It's been going for a little bit. And then I can also, so we can run that command to see what's running within the class. And then there's also this log file. And so I'm going to cat the log file. And let's see what we get. So it's giving something. So it's saying con 1001 struck. And so I'm going to go into the OA directory. And now what we can see, so I went up into the CD, I went up a level and then down into OA VBM directory, so navigated. And now what we can see is there is a directory called struck in here for structure. And I can go into there, I can list the contents. And so now these files are being renamed and they're being copied into there and renamed, just putting struck on the end. And then it will start to do the processing. So we can see the first participant has a brain on the end. So this is brain extracting. And so that's doing the first step. Hasn't caused any issues, hasn't run into any issues yet. And I can still verify that it's running. It's been running now for about 2 minutes, so we should be good to go. So that's the first step. And then once this finishes, then we can do the rest of the analyses. And so that's going to take a while. So the video for that will be coming later.